Okay, so I think this is a video 40 now. So 3.3.1. So marginal product and average product. We go ahead and define these things here. Yeah. So we will extensively use the following two concepts, marginal product and average product. Yeah. You should know at this point that whenever we use the term marginal, we are talking about a derivative, correct? We've said it like 10 times. Since our function f has two variables, we are interested in two partial derivatives, the marginal product of labor and the marginal product of capital. So we have it right there, very, very easy. Get into some basic definitions and some actual math a lot better, but we take the derivative of the production function with respect to L. It's the marginal product of labor, the marginal product of labor. Yep. We take the partial derivative of our production function with respect to K. It is the marginal product of capital. Yeah, so the marginal product of labor tells us how fast the output Q goes up as we marginally increase the amount of labor we use given some fixed amount of capital. This partial derivative is an approximation of how small changes in L affect Q, the same for all derivatives that exist and all marginal that exist. Marginal derivative are the same word in microecon, holding K constant. So always with it's that technicality they can tell us, but with all partial derivatives, when you take a partial, all other things in there are held constant. Yeah. Take the partial derivative with respect to labor, and K is held constant. Take the partial derivative with respect to K, which is actually capital. The labor would be held constant. And if there's 7 variables, take the partial derivative with respect to this over here. 6 of them would be held constant. Yeah, so silly little things like that. Okay, so hence sometimes it is convenient to think about MPL, the marginal product of labor, as uh, how much more output we can produce if we add 1 extra unit of labor. It is not really a full extra unit of labor. We're talking about a marginal increase, but it is a useful approximation. Yeah. Every single little thing. So you just, you add one more X, you add one more X, just add one more X, and it's the increase in Y or the increase in the up. But the word marginal, just interrupt myself, and this stuff is not important, but the word marginal kind of sort of like all calculus means an infinitely small piece, which is actually less than 1, but we don't really care. They never define that. It's both are true at the same time. In the one case, marginal means the increase in Y with a freakishly small increase in X. On the other hand, marginal also means the increase in Y when we increase X by 1. So kind of a contradiction, but it does mean all of that. All of that is in there. Yeah. Oh, I interrupt myself too much. Okay, so hence, sometimes it is convenient to think about MPL as how much more output we can produce if we add 1 extra unit of labor. It is not really a full extra unit of labor. We're talking about a marginal increase, but it is useful approximation. The equivalent idea holds for the marginal product of capital. It is a measure of how increasing capital affects the output for the technology. This is a yeah, it's just terminology, very, very easy. I don't want to call it the quantity function, but we define this stuff and then we instantaneously forget it. So I know all of this fairly well once I learn it, but then forget it the next day. But anyways, so the Cobb-Douglas function is we described it in the last video. The what the functions are called. Yeah, the production function. It's the production function. It's just vocabulary, but sometimes I pause because I forget the simplest thing there. And et cetera, et cetera. So a production function, of course, is the Cobb-Douglas function for the technology that figure 3.2a. So now we kind of get back into this stuff here. Good, so they have this here. Output is a function of labor, marginal product. The one on the right, B, looks to be more Cobb-Douglas to me. Yes. But they're going to describe this now. So figure 3.2 production function this, holding K equals 25. Yeah. Okay. So this here is the output. It's the quantity. This is the quantity. Yeah, as a function of labor, where labor is just an integer, 1 unit of labor, 2, 3, 4. The production function, this is the partial derivative. Yeah, the partial derivative of the production function. Maybe call it Q. The partial derivative of Q with respect to L. Okay, so yes. So these slopes here, all the slopes, this is the partial derivative. So all those slopes are the y values over here. These slopes over here are the y values over here. It's always a good question, why do they do these graphs? But I'm just trying to kind of quick give my own analysis of the graph there. Let's take a look here. For the technology that figure 3.2a that we're just looking at depicts how much Q we can produce for different levels of labor L holding capital constant at K equals 25. The marginal product, yeah, so they take the derivative. That's just going to be the partial with respect to L, so they have that over there. In our example, we're holding K equals 25, thus NPL equals that. When we plug in 25, when the firm uses 2 units of labor, we have MPL is approximately that. Hence, what is MPL? It's the marginal. MPL is the marginal product of labor. Hence, if we add 1 extra unit of labor, output Q will go up with approximately 26.4 units. Yeah. When the firm uses 2 units of labor, we have this right here. Hence, if we add 1 extra unit of labor, yeah, so we always misinterpret. I don't want to misinterpret that, but it's like, where do they come out with a 2 there? Yes, hence, if we add 1, etc. 2, I'm sorry, here. Yeah, what they do is they have this, and for L, they literally plug in a 2. See, there it is right there. So they plug in 2 units of labor. So when you do that, this is actually for the third, I think. Hopefully we're defining that correct. Yeah, it's just, why would they plug in 2? They could have plugged in a 4. They could have plugged in anything, yes. But if, yeah, if L equals 2, so we kind of write that there for an example. If L equals 2, then the MPL, the marginal product of labor, is 40 over 2 to the 0.6 is approximately 26.4. I think it's actually talking about the third. I mean, we can't really add a fraction of labor, although we actually kind of can, because maybe the marginal, that tiny little increase in the horizontal, maybe it wants to be very small. But if we add the third there, yeah, if we add the third, we're not plugging the third into here. No, yeah. We're just saying if we add 1 more after that, the up, the Q, the vertical, the Q is going to increase by approximately that much right there. So the 2 doesn't have much to do with it. It's just at 2 units of labor, this is true. At 2 units of labor, maybe the third, yeah, is going to increase it by approximately 26.2. It doesn't mean that plugging in 2 makes it increase that. It doesn't mean that right there. So it can be very, very, very confusing. We're going to have to continue this here in the next video here, I think.